In 1972, a motorcycle company from Japan built an engine that passed emissions tests every car maker in America said were impossible. They didn't even have a car to put it in, so they bolted it into a competitor's Nissan, loaded sandbags in the trunk for weight, and shipped it to Michigan. It passed. Now, to understand why that matters, you need to understand what was happening in America in the early 1970s. The country was choking, not metaphorically, literally choking. Los Angeles had become a permanent brown haze. On bad days, you couldn't see the mountains from downtown. Children were kept inside during recess because the air outside was considered dangerous. Cities across the country, not just LA, were recording smog levels that sent people to the hospital. Pittsburgh, Gary, Indiana, Houston. The problem was everywhere cars were, and the cars rolling off the assembly lines in Detroit were a big part of the reason. The average American V8 was an engineering marvel of a very specific kind. It converted gasoline into horsepower with almost reckless enthusiasm and zero concern for what happened after the power stroke. A typical family sedan had a 350 or 400 cubic inch engine under the hood, burning through fuel like it was free, which, honestly, it almost was. Gas cost about 38 cents a gallon. $1 could practically fill your tank. Nobody thought about efficiency. Nobody thought about what came out of the tailpipe. The prevailing attitude in Detroit was simple. The customer wanted power and size. Give them power and size. Everything else was someone else's problem. The numbers were staggering. Every car on the road was essentially a small, mobile pollution factory, and there were over 100 million of them on American roads. Then Senator Edmund Muskie from Maine decided they should start caring. In 1970, Congress passed the Clean Air Act, and Muskie put teeth in it. The law demanded a 90% reduction in carbon monoxide, hydrocarbons, and nitrogen oxide emissions from automobiles by 1975. 90%. That wasn't a gentle nudge. That was a shove off a cliff. And the kicker? The standards were deliberately set beyond what existing technology could achieve. Congress wanted to force the industry to innovate. Detroit's response was predictable. The heads of General Motors, Ford, and Chrysler marched into Senate hearings and testified under oath that these standards were physically impossible to meet. Not difficult, not expensive, impossible. They argued no technology existed or could exist in time to allow their engines to comply. They asked for extensions. They lobbied. They pushed back with everything they had. And honestly, they had a point. Sort of. The conventional approach to cleaning up exhaust was the catalytic converter, a device bolted to the exhaust system that chemically converted pollutants into less harmful gases. But catalytic converters had problems. They were expensive. They robbed engines of power. They ran hot enough to start fires. They required unleaded gasoline, which wasn't universally available, and they wore out. The whole industry was stuck in the same rut, trying to clean up the mess after combustion rather than preventing it in the first place. 6,000 miles away, in a research lab in Saitama, Japan, a small team of engineers was taking a completely different approach. And the company they worked for wasn't even really a car company yet. Honda Motor Company in 1970 was primarily a motorcycle manufacturer. The largest in the world, yes, but still. Motorcycles. Cars were a sideline. Their automotive lineup consisted of a handful of small, quirky vehicles that most Americans had never heard of and fewer had driven. The slow-selling Honda 1300 had been an engineering curiosity. The tiny N-Series cars were barely bigger than go-karts. In the American market, Honda meant one thing: bikes. The company's founder, Soichiro Honda, was 64 years old, a self-taught engineer who'd started his career as a teenage mechanic's apprentice in Tokyo. He didn't finish school. He didn't care. At 15, he left home and walked into an auto repair shop called Art Shokai and asked for work. He spent 6 years there learning everything from engine repair to customer service, and when he left, he opened his own shop. Then, he started racing, built his own cars from scrap. In 1936, he crashed at the All-Japan Speed Rally after setting a speed record of 120 kilometers per hour. The crash nearly blinded his left eye. He went back to engineering. During the war, his company, Tokai Seiki, made piston rings and aircraft engines. An American bombing raid destroyed one factory. An earthquake collapsed the other. After the war, Honda sold the salvageable remains to Toyota for a small sum and used the money to start over. He strapped surplus military engines to bicycles, built a company from there, grew it into the world's largest motorcycle manufacturer by 1959, and then, against the explicit wishes of the Japanese government, which wanted to limit the auto industry to established firms, he started making cars anyway. Soichiro Honda was not a man who accepted conventional wisdom. When his engineers told him something was difficult, his standard response was to publicly announce that Honda would do it, then tell his team they'd better figure it out. He called this approach leaving everyone upstairs and taking away the ladder. In 1965, Honda established what they called the AP Lab, Air Pollution Research Group. At the time, Honda's engine expertise was focused entirely on power and high revs. Emissions weren't even an afterthought. The team leader, a researcher named Tasuku Date, later admitted they didn't even know what nitrogen oxides were when they started. They had to ask. Japan didn't have the equipment to measure them. They were starting from zero. But Date, along with engineers Shizuo Yagi and Kazuo Nakagawa, began studying the problem from first principles. The fundamental challenge was this: a gasoline engine needs a rich fuel-air mixture to ignite reliably and produce power, but a rich mixture burns dirty, producing carbon monoxide and unburned hydrocarbons. A lean mixture burns cleaner, but it's hard to ignite, produces less power, and generates more nitrogen oxides because of the higher combustion temperatures. Every solution created a new problem. The whole industry was trapped in this paradox. On the advice of a University of Tokyo professor named Tsuyoshi Asanuma, Date's team explored an idea borrowed from diesel engines, a pre-chamber. What if you didn't have to choose between rich and lean? What if you could have both in the same cylinder at the same time? The concept was elegant. Take a standard cylinder and add a small auxiliary chamber above it, separated by a perforated metal plate. This tiny pre-chamber gets its own inlet valve and its own fuel supply. Feed it a rich, easily ignitable mixture. Meanwhile, the main combustion chamber below receives a very lean mixture through the standard inlet valve. The spark plug sits in the pre-chamber. When it fires, the rich mixture ignites easily, sending a jet of flame through the perforations and into the main chamber. This flame jet creates a vortex, a swirling pattern of fire that ignites the lean mixture in the main chamber thoroughly and completely. The result? The engine runs on an overall lean mixture, which means less fuel consumption and lower emissions of carbon monoxide and hydrocarbons. But the controlled combustion process also keeps temperatures lower than a conventional lean burn engine would, which reduces nitrogen oxides. They solved the paradox, not by cleaning up after combustion, but by reinventing combustion itself. In January of 1970, they completed a test version using a single-cylinder, 300 cubic centimeters engine from a Honda N600. The early results were promising, but promising isn't the same as proven, and Soichiro Honda wasn't about to wait for proof. On February 12, 1971, Soichiro held a press conference at the Keidanren building in Tokyo and announced to the world that Honda had the prospect of developing an engine that would meet the 1975 American emission standards. This was more than 4 years before the deadline. They hadn't finished developing the technology. They hadn't even decided what fuel delivery system to use yet. The team was still deep in research. When asked why he'd make such a bold claim before the work was done, Yagi later explained that Soichiro told them if he waited for the engineers to say they were finished, the company would go bankrupt first. So the ladder was gone. The team had no choice but to deliver. They named the technology CVCC, Compound Vortex Controlled Combustion. The name was deliberately vague. They were still filing patents and didn't want to reveal the pre-chamber design to competitors. Date later said they wanted something punchy that wouldn't give away the technical details. Over the next 20 months, the team built roughly 100 prototype engines. They bench-tested them, refined them, and then faced a practical problem. Honda didn't have a car big enough to install the engine in. The Civic was still being developed. So they did something that still makes me laugh. They installed their revolutionary Honda engines into Nissan Sunny bodies. They put sandbags in the cars to simulate proper vehicle weight. And that's how the most important emissions breakthrough of the 20th century got tested. In a competitor's car, stuffed with sand. October 11th, 1972. The Akasaka Prince Hotel in Tokyo. Honda unveiled the CVCC engine to the global press. The room was decorated in blue panels meant to represent clear skies. Every company director was there. Soichiro Honda himself was there. And the engineers made two claims that sent shockwaves through the auto industry. First, the CVCC system could be adapted to existing engines. You only needed to modify the cylinder head. Existing factories, existing tooling, all usable. Second, the engine met emission standards without a catalytic converter. No unleaded fuel requirement, no power-robbing exhaust devices, just a better way to burn gasoline. The EPA wanted proof. They invited Honda to send cars to their laboratory in Ann Arbor, Michigan. Honda shipped 3 vehicles, 2 with 15,000 miles on the odometers, 1 with 50,000 miles from durability testing. All of them Nissan Sunny bodies with Honda engines. The testing ran from December 7th through 14th, 1972. The Honda CVCC became the first engine in the world to clear the stringent 1975 emissions requirements of the Clean Air Act. While Detroit was still testifying before Congress that meeting these standards was impossible, Honda had already done it. In someone else's car. If you're enjoying this, hit subscribe. We cover stuff like this every week. Okay, back to it. Now here's where the engineering gets really interesting. Let's talk about what actually happens inside a CVCC cylinder, because the elegance of this design is something else. The cylinder head has 3 valves instead of the usual 2. There's the standard intake valve, the exhaust valve, and a small auxiliary intake valve that feeds the pre-chamber. The main combustion chamber receives a lean air-fuel mixture, roughly an 18-to-1 or even 20-to-1 ratio. For reference, a conventional engine of that era ran around 14-to-1, so the main charge has considerably more air relative to fuel than normal. Meanwhile, the tiny pre-chamber, which is only about 5 to 8% of the total combustion volume, receives a rich mixture. Around 8-to-1. This is easy to ignite. The spark plug fires, the rich mixture catches immediately. And here's the clever part. The flame front doesn't just drift into the main chamber, it jets through the perforations in the dividing plate at high velocity, creating a swirling vortex pattern. That's the V in CVCC. This vortex distributes the flame energy throughout the main chamber far more effectively than a single spark plug could ever manage in a lean mixture. The combustion is fast, thorough, and complete. Almost all the fuel gets burned. That means dramatically lower hydrocarbons and carbon monoxide in the exhaust. And because the overall mixture is lean and the combustion temperature is lower than what you'd get in a conventional engine trying to burn lean, nitrogen oxide formation drops significantly too. The numbers bore this out. The CVCC engine met the 1975 standards for all 3 major pollutants, without a catalytic converter, without an air injection pump, without exhaust gas recirculation, just the engine itself, doing its job properly. But there was something else the EPA testing revealed, something that would matter even more than emissions in the years to come. The CVCC engine was remarkably fuel efficient. When they later tested it in the Civic, it earned 27 miles per gallon in the city and 39 on the highway. It was ranked the most fuel-efficient car in America for 4 consecutive years, from 1975 through 1978. The design had another practical advantage that's easy to overlook. Because it didn't need a catalytic converter, the CVCC Civic could run on leaded or unleaded gasoline. In the mid-70s, unleaded fuel wasn't available everywhere. Some gas stations, especially in rural areas, only carried leaded. Every other new car on the American market needed unleaded fuel to avoid destroying its catalytic converter. The Civic could pull up to any pump and fill up. That flexibility was about to become very, very valuable. Now, December 13, 1972. Toyota signed a licensing agreement with Honda for the CVCC technology. This was significant. Toyota was the biggest automaker in Japan. For them to license technology from Honda, a company many in the industry still thought of as a motorcycle maker, was a major validation. The news hit the papers, and immediately Honda started getting calls from manufacturers around the world. Ford signed on, Chrysler signed on, Isuzu signed on, but not General Motors. The largest corporation on the planet looked at what Honda had done and was not impressed. The thing about GM in 1973 is that they were enormous. They controlled roughly half the American car market. They employed over 800,000 people. Their annual revenue was larger than the GDP of most countries. When GM said something couldn't be done, the assumption was that it couldn't be done. GM's chairman, Richard Gerstenberg, publicly dismissed the CVCC technology. His exact assessment, as widely reported, was that while the design might work on a small motorcycle engine, he'd like to see it work on one of GM's car engines. The implication was clear. Honda's little trick was fine for tiny foreign cars, but it had no relevance to the real engines made by real car companies in Detroit. Soichiro Honda heard this, and he took it personally. Now, Honda's engineers had actually been experimenting with American engines already. They'd fitted the CVCC system to a Chevrolet Vega 4-cylinder as early as 1972 and improved its fuel economy from 17.2 miles per gallon to 18.9. But a Vega was a small car. Gerstenberg hadn't been talking about small cars, so Soichiro went out and bought a 1973 Chevrolet Impala, a full-size American sedan with a 350 cubic-inch V8, 5.7 liters. This was not a small engine. This was the exact kind of engine Gerstenberg said the CVCC couldn't help. Honda had the Impala air-freighted to Japan, across the Pacific, because shipping would take too long. His engineers designed and cast new CVCC cylinder heads for the Chevy V8. They modified the intake, manifold, and carburetor. They did not add a catalytic converter. They did not add an air pump. They did not add exhaust gas recirculation. They changed the heads, the manifold, and the carburetor. That's it. Then they flew the car back to Ann Arbor and handed it to the EPA. Test it. The results came back. The CVCC-equipped Impala V8 met and surpassed the 1975 and 76 hydrocarbon and carbon monoxide standards. Horsepower held at 160. Some tests showed a slight improvement in fuel economy. The technology that GM's chairman said was only good for toy motorcycle engines had just made GM's own V8 cleaner than GM could manage. Honda published the results for everyone to see. Meanwhile, the timing of everything that followed was almost supernatural. In October of 1973, the Organization of Arab Petroleum Exporting Countries declared an oil embargo against the United States. The trigger was the Yom Kippur War. Egypt and Syria launched a surprise attack on Israel. The United States rushed military aid to the Israeli side, and the Arab oil producers retaliated. They raised prices, banned shipments to America, and cut production by 5% every month. The price of crude oil quadrupled in months, from about $3 a barrel to nearly $12. Gas stations ran dry, lines stretched for blocks. You'd wait 2 or 3 hours just to get fuel, and when you reached the pump, you might be limited to 10 gallons. President Nixon asked gas stations to voluntarily stop selling fuel on Saturday nights and Sundays. 90% complied, which only made the panic worse. Up to 20% of gas stations had no fuel at all during the worst weeks. States imposed odd-even rationing based on license plate numbers. Congress dropped the national speed limit to 55 miles per hour. Oregon banned Christmas lighting to save electricity. Gas prices jumped 43% in barely a year. The economy tipped into stagflation, recession, and inflation simultaneously. People traded in their mammoth sedans and started eyeing small foreign cars they would have laughed at 12 months earlier. America was suddenly painfully aware that it was addicted to gasoline, and the cars it drove drank the stuff like there was an infinite supply. The Honda Civic CVCC went on sale in Japan in December of 1973. The timing was, to put it mildly, perfect. The Japanese auto industry as a whole saw production drop 7.5% that year. Honda was the only manufacturer to record a major increase in sales. Their production jumped to 430,000 cars. Sales rose 21%. Demand for the Civic was so strong that Honda actually stopped making their key cars entirely just to build more Civics. The American market debut came with the 1975 model year. The EPA certified it. The inspector shook the hand of Honda engineer Takeo Fukui and said, "Congratulations." Then he told Fukui something else. The Civic CVCC had received the highest fuel economy rating of any car tested. At a sticker price of $2,729, it was also the most affordable car on the American market. Think about what Honda was offering in 1975. The most fuel-efficient car in the country, the cheapest car you could buy. It ran on any gasoline, leaded or unleaded. It didn't need a catalytic converter. It met the emission standards that Detroit said were impossible, and Americans were standing in line for hours just to get gas. Honda ran advertisements with the slogan, "Any kind of gas." While competitors' cars were chained to unleaded pumps, the Civic pulled up to whatever was available. In an era of fuel rationing and panic, that wasn't just convenient. It was freedom. This went about as well for Detroit as you'd expect. The production numbers tell the story. First-generation Civic production topped 1.1 million units. The car won Japan's Car of the Year award from 1972 through 1974. It finished third in the European Car of the Year rankings, the highest placement ever achieved by a Japanese car at that time. American magazine Road Test named it Car of the Year in 1974. A car that weighed less than 1,500 pounds and made about 53 horsepower was suddenly the most desirable vehicle in the land of the muscle car. The consequences rippled outward in every direction. Ford had been negotiating seriously with Honda about a partnership. They wanted to import CVCC engines, possibly sell the Civic under the Ford name, and explore a capital alliance. Honda's business partner, Takeo Fujisawa, was cautious. A capital tie-up was off the table. But the negotiations opened the door for Honda to sell cars in America more broadly. The talks revealed something interesting about the power dynamic. Ford, one of the largest companies on earth, was coming to Honda, not the other way around. General Motors, eating humble pie, approached Honda about buying 200,000 to 400,000 CVCC engines per year. They didn't want to license the technology. They wanted Honda to be a parts supplier. Honda had zero interest in this arrangement. They didn't have the manufacturing capacity for it anyway, and being a GM supplier would put them in a subordinate position they had no intention of accepting. The broader industry scrambled. The EPA held a hearing in March of 1973 where Honda and Mazda were the only two companies that could demonstrate compliance with the upcoming standards. The EPA asked Honda if they could supply engines to the rest of the industry. Honda said no. They were barely keeping up with their own production. Richard Nixon signed a delay into law in 1974, pushing the carbon monoxide and hydrocarbon standards back to 1977, and nitrogen oxide standards to 1978. Detroit got its extension, but the damage to its reputation was done. A motorcycle company from Japan had accomplished what the mightiest industrial corporations in America claimed was beyond the reach of human engineering. The oil crisis transformed the American car market permanently. Before 1973, fuel efficiency was an afterthought. After it, fuel economy stickers became mandatory on every new car. Automakers were forced to invest in smaller, lighter, more efficient vehicles, and the Japanese manufacturers, led by Honda and Toyota, were suddenly the companies consumers wanted to buy from. They'd been building small, efficient cars all along, not because they were environmentally enlightened, but because that's what the Japanese market demanded. Narrow roads, expensive fuel, limited space. The engineering philosophy born from those constraints turned out to be exactly what America needed when the rules changed overnight. Honda's success with the CVCC had implications beyond the Civic. The technology proved that the cylinder head was the key to emissions control, not bolt-on aftermarket devices. This shifted the entire industry's thinking about engine design. The pre-chamber concept influenced decades of subsequent combustion research. Modern gasoline direct injection engines, turbocharged lean burn designs, and even some diesel technologies owe intellectual debts to the stratified charge principle that Honda commercialized. The CVCC also proved something about the nature of innovation. The Big Three had more engineers, more money, and more resources than Honda by orders of magnitude. General Motors alone employed more people than the population of some countries. And yet, a company with a fraction of their budget, starting from near total ignorance about emissions, solved the problem first. Not because they were smarter, because they weren't locked into the assumption that the only way to clean exhaust was to treat it after it left the engine. The CVCC technology itself didn't last forever. As emission standards continued to tighten through the 80s, the combination of electronic fuel injection and three-way catalytic converters proved more effective. Honda phased out CVCC in favor of their PGMFI, Programmable Fuel Injection System. The 1981 amendments to the Clean Air Act pushed standards beyond what CVCC alone could handle, and Honda, characteristically, moved on to the next challenge rather than clinging to old technology. But the legacy is enormous. In 2007, the Honda CVCC engine was added to Japan's Mechanical Engineering Heritage List. The first-generation Civic, the car that nobody expected to matter, sold over 1.1 million units. It won Car of the Year in Japan 3 years running. It placed third in the European Car of the Year rankings, the highest finish for a Japanese car at that time. More importantly, it changed what people believed was possible. Before the CVCC, the American auto industry operated on the assumption that emissions and performance were a zero-sum game. You could have power, or you could have clean exhaust. Honda proved that was a failure of imagination, not a law of physics. Soichiro Honda retired from the company presidency in 1973, right as the CVCC Civic was beginning its conquest of the global market. He never held a management position again, and despite accepting the title of Supreme Advisor, he never offered advice to his successor. Neither he nor any member of his family held major stock positions or management roles in the company. He'd built one of the great industrial enterprises of the 20th century, and he walked away from it. Not because he'd lost interest, because he believed it was the right thing to do. He received Japan's highest imperial honor and was inducted into the Automotive Hall of Fame. The American Society of Mechanical Engineers created a medal in his name. He died in 1991 at the age of 84. By then, Honda Motor Company was the third largest automaker in Japan and the largest motorcycle manufacturer in the world. The Civic was in its fifth generation. The Accord had become the most popular car in the United States. Honda had opened its first American manufacturing plant in 1979. It all traces back to a team of engineers in Saitama who didn't know what nitrogen oxides were, a founder who announced success before it existed, and a tiny pre-chamber in a cylinder head that changed the rules of the game. They didn't have the biggest budget. They didn't have the most engineers. They didn't even have their own car to test the engine in. They had a better idea. And that was enough. And there you have it. The story of how a motorcycle company embarrassed the most powerful auto industry on Earth with a hole in a cylinder head. If you've ever owned a Civic, or if you think I got something wrong, drop it in the comments. Subscribe if you want more of these. We do this every week.